Hi, welcome to the simulated labs for Opti 471B. Today we'll be going over the shear plate and the Shack cube interferometers and analyzing them using non-sequential ray tracing in Zemax. The video setup is similar to previous weeks, but since there's two labs that we've already seen before, I'll be going faster through the theory and the setup of both. First is the shear plate interferometer. Now this interferometer functions by superimposing two beams that are reflected off of the front and the back surface of a shear plate. For a non-wedge shear plate, the setup is exactly as the diagram is shown above. But for a wedge shear plate, that back surface is slightly tilted. This setup was pretty easily put together in Zemax with four simple components. First was a point source that was collimated using a lens taken from the Thor Labs catalog. Next was the rectangular shear plate, followed by the detector above it. To switch between wedged and non-wedged shear plates, a tilt was added to the back surface of that plate. Some of the significant results for the wedge shear plate are shown here. With zero aberration, the wedge in the shear plate still causes linear fringes to appear. All other aberrations are added on top of those already existing linear fringes. Defocus has the effect of tilting those fringes, hence making this interferometer a good tool for testing collimation. Yet the interferometer is fairly insensitive to decenter and tilt of the collimation lens. The non-wedge version has no inherent linear fringes. Instead, linear fringes arise from the addition of defocus. Another interesting thing happens when the collimation lens is flipped so that it's at a maximum spherical aberration orientation. When combining this with defocus, the interferogram can be balanced so that there's the least amount of fringes. Next is the Shack cube. This interferometer gets its reference wavefront from an embedded spherical reference surface. This allows you to read the interferograms like you're reading a contour map. This setup was created using an aspheric focusing lens from Admin Optics. A key point of this setup is that the reference surface had the same radius of curvature as the incoming wavefront that was reflected off of the test mirror. The results were as follows, where the interferograms could be read like contour maps. As you'll notice though, this interferometer was much more sensitive to changing the position of the mirror. Spherical aberration could also be added by adding a conic term to the mirror. These are all interferograms that have been seen and analyzed in previous labs, so I'll stop here for today. Thank you for watching.